Let's explore how to find the nth derivative of the exponential function y equals e to the x. Let's start by looking at our initial function. We begin with y equals e to the x. When we take the first derivative, using the chain rule, we get y1 equals a times e to the x. Taking the second derivative, we differentiate again and get y2 equals a square times e to the x. For the third derivative, we get y3 equals a cube times e to the x. Let's visualize this pattern. Notice how with each derivative, we multiply by another factor of a while keeping the e to the x term. From this pattern, we can make a general rule. The nth derivative will be a to the n power times e to the x. Let's verify this with a specific example. Say we have a function y equals e to the 2x, so equals 2. Let's calculate the first few derivatives. Notice how the coefficients are powers of 2. 2 to the first 2 squared, 2 cubed, and 2 to the fourth. This confirms our general rule that the nth derivative will have a coefficient of a to the n. And that's how we can find the nth derivative of e to the x. The key is recognizing the pattern where each derivative multiplies by another factor of a while maintaining the exponential term.